So thank you for attending my talk. I'll start off with a little bit about myself. So this is me. Every time I visit a new city or a new country, I take this exact picture with my Palestinian flag. And this, if it's not obvious, because the picture was taken in a bad way, but this is in Beijing. It's one of my latest travels. It's in Beijing, and it's on top of the Great Wall of China. And it's my first time in Quebec, so I'm looking forward to adding a new picture to my collection if the weather is better. Yeah, I'm literally afraid of getting blown away. Okay, so when I'm not traveling, I work as a security assessment analyst. What that entails is I do vulnerability assessments on web applications, which really ties in with the research that I did a year ago in my master's under the supervision of Dr. Carlisle Adams, and that's the topic that I'll speak about today. So just a quick word about my supervisor. He's pretty famous in the cryptography community. I'm not so sure about the security community, but if you're ever in the same place as him, please do strike up a conversation with him. He's not only one of the nicest guys you'll meet, but also one of the smartest. He created an algorithm called CAST, which is used in many of the systems. It competed with the advanced encryption standard. It came in sixth, but the advanced encryption standard obviously won and got standardized. So yeah, do talk to him if you see him. I spoke about my research in several places, and every time I would say it in a way that the research was conducted. So I would go through the entire methodology, how it was done, and then the excruciating details of the results of the research. And I usually felt like I lost the audience by the end of it, or at least half the audience by the end of it. So instead, for today, I'm going to say it in a form of a story. So I had a lot of fun creating these slides. I hope it's fun for you guys to listen to the presentation as well. Okay. So this is Johnny. He's a fresh off the boat grad student. Well, he just graduated from his computer science degree where he learned how to develop web applications. And because he was top of his class, he got hired at a company right away. And the first thing that his boss told him, considering all the recent breaches, is that you need to develop secure code, right? And the university system, as usual, has failed Johnny and hasn't taught him any secure coding practices or security in general. So Johnny did what every computer science student would do if they didn't know how to perform a certain thing. Anyone want to guess what that is? Exactly. He Googled it or Stack Overflowed it, whatever. And yeah, so he Googled web application security, and these results are actually real. I just omitted the scanner names. So yeah, he found the answers that he was looking for. So Commercial Scanner X ensures web application security by securing your website and web applications against hacker attacks. And the results become even more promising. Commercial Scanner Y, dead accurate web vulnerability scanner to identify vulnerabilities in your websites. And not only is there commercial ones, there's also open source ones. So Johnny doesn't even have to convince his employer to buy a 20K scanner. He could just use an open source one. So he had a genius idea, or what seemed to be genius at the time, that all he has to do is develop code, which he already knows what to do, how to do it from university. And then he runs the web application vulnerability scanner on his deployed application, and it looks for vulnerabilities. If it doesn't find them, then he's good to go. His application is bulletproof. If it does find vulnerabilities, he'll go through the loop cycle again. He'll make changes to his code to remediate the vulnerabilities, run his web application vulnerability scanner on it again, look for vulnerabilities, and go through the entire loop until no vulnerabilities are found. And because no vulnerabilities are found at the end, then his application is bulletproof, right? And so that worked out great for Johnny. And he thought he's a freaking genius. He added security analyst and security specialist to his LinkedIn title after this, because apparently he figured out how to pen test, how to do vulnerability assessments, how to do security assessments, and so on, just by running these tools, right? And so when the organization decided to hire external consultants to perform a vulnerability assessment or a pen test, they're different, so a pen test, on the organization, and that included Johnny's web application, it found so many vulnerabilities. And notice over here the infinity at the end. And so this obviously left Johnny very confused. He was like, and with so many questions, like, how do these tools work? Because he ran the tools on his web application and they didn't find any vulnerabilities. So, why is that? Is there any special configuration that these tools require? Was it an error from Johnny on how he ran the tools? And that's why the scanners didn't find any vulnerabilities. How much coverage do they achieve? So the way the scanners work is that they crawl your web application and then they look for vulnerabilities. If they're not crawling the entire application, then they're not getting to the pages that are vulnerable, right? And so was it a crawling coverage issue? What vulnerabilities can the scanners find? And more importantly, what vulnerabilities can they not find? And so Johnny decided to embark on a research journey to figure out the answers to his questions. And the first question was, how do these scanners work? What are they made up of? And at a high level overview, they're made up of 3 components: the crawler module, the attacker module, and the analysis module. The crawler module is used to map the application. So what it does is it starts off with a URL or a set of URLs that are taken as seeds of the application. It starts off there and it visits any links and redirects that it sees from these URLs. So it essentially crawls the application and maps it out, and makes point of any input vectors that are available on these links. And then there's the attacker module, which takes the links and input vectors that the crawler module found, and then it crafts malicious payloads to insert into these input vectors. And then the analysis module takes the responses from the attacker module and analyzes the response in order to determine if a vulnerability actually exists. Okay, so now we know how these scanners work at a high-level overview. How should they be used? Because again, the way that Johnny used them, it ended up not finding any vulnerabilities, and the pen test reported so many of the vulnerabilities. So the first option is point and shoot, and that's the option that is usually pushed by vendors and advertised by vendors, and unfortunately the option that most people use. And the idea is that you give the scanner the URL of your website or the domain name, and then you ask it to scan the site. So there's very minimal human interference with the whole entire process. All you have to do is give it a URL of your application and then ask it to scan the site. And it's shocking how many people use these scanners this way, and it's pretty sad. And we'll see why that is in a bit. The second option, which is a little bit better, is called trained or configured. And it pretty much entails a list of steps that you have to do in order to train your scanner and configure your scanner to maximize its crawling coverage and vulnerability detection. And one of these things is setting the scanner in proxy mode. So if the scanner has a proxy component, what you would do is put it in the middle between your browser and your web application. And then any request that you send through your browser will first pass through the proxy, so through the scanner, and then go back to the web application. And then any response from the web application goes through the scanner and then gets relayed back to you in the browser. And the reason that that is good is that in case the scanner can't crawl the application by default because it doesn't have a good crawler, or the technologies that are being used are very complex, then when you set it in proxy mode and you're visiting all those sites on your own manually, then it's getting recorded in the scanner. So the next time you decide to scan the site, it has a record of all these links, and it will actually scan those links for vulnerabilities. Another thing would be to change the configuration. So you have to think of these scanners like a child. You have to hold its hand, go like, sweetheart, I want you to do this thing, and this is exactly how you do it. So in terms of like logging in, scanners are able to create an account. So they're able to create accounts, but they don't figure out that they've actually created an account, and so they never use that account to log back in. So if you want them to authenticate, you actually have to give them the username and the password. and tell them this is login credentials. And then on top of that, you have to take out the logout link to make sure that they don't accidentally click it and then unauthenticate themselves. So any requests to any authenticated pages after that end up going in unauthenticated mode. So they kind of error out as opposed to look for vulnerabilities. So things like that, and we'll talk a little bit more about that later. So now that we know how the tools work and how they should be used, the next step would be to select the tools that we want to evaluate. And that was done based on Shay Shen's evaluation, where he evaluates 64 scanners every couple of years. It's about every 3 years. And they're both commercial and open source. And he evaluates them on an application he created called WaveSap, and all the results are available on the SecTool Market website. So we picked the top 10 performing scanners, and then we consulted with professional penetration testers and asked them which of these scanners are used in real life in corporate environments. And we ended up with 6, 5 open source. So we've got Arachne, Skipfish, Viga, Wapiti, and Zap, and 1 commercial, which is Burp Suite Pro, because Sportswagger was nice enough to give us a license. When we asked for other licenses from other vendors, they said no right away for obvious reasons. And that will be, here we go. And that'll be more obvious as we progress through the presentation. Okay, so the environment set up for doing the testing was this. We had a VM that was restored to its initial state with every test run. We had our tools, so that's the one on top. And then we had the applications that we tested our tools against. So WaveSap was the one that we saw in the previous slide. That's the one that was created by Chen. It has over 1,000 vulnerabilities that fall into different categories. There's also Wivet. That application does not contain any vulnerabilities. It contains crawling challenges, so it's used to measure the crawling coverage of an application. So what it does is it has a bunch of different technologies, and if the application is able to crawl and get to these technologies, then it's marked as a yes, it's able to crawl it. If it's not, then it's marked as a no, as a test failed. So things like dynamic JavaScript, AJAX requests, comments, and links, because that's a way to enumerate your application even more, and so on, multi-step processes and so on. And we'll see a lot of that in the next coming slides. Wacko Pico is the application that our research is largely dependent on. So we use all 3, but it's largely dependent on this one. And that was created by Dupay AL, and the research was done 8 years ago and published. It was mostly on commercial scanners, and the research was called Why Johnny Can't Pen Test, a comparative analysis of web application vulnerability scanners. And the results were horrible, obviously, and hence the name. And so our research was to conduct the research that they did, but in a more updated fashion with more analysis, and on open source scanners as opposed to commercial ones. Okay. All right, so the results. So if it sounds too good to be true, it probably is. So remember the promises that we saw on the Google search, that accurate scanner finds all your vulnerabilities, secures your web application, so on. Well, here are the results. So here are sample vulnerabilities that the scanners were not able to detect. So weak authentication credentials, the web application had an admin page, which the scanners were aware of because you can see that the scanner visited that page. And the credentials were admin. And none of the scanners detected that vulnerability because they don't even try to brute force that vulnerability in the first place. They're not made for that. You use specialized tools like Hydra and John the Ripper or whatever to do that stuff for you. But scanners themselves, they don't test for weak credentials, and that's on the OWASP top 10, right? There's a commercial scanner that goes like it tests for the OWASP top 10. I'm like, do you? But anyways. Parameter manipulation. So in the application, there was a vulnerability where, as an unauthenticated user, you can see a sample user's page by just, and it's identified by the user ID being equal to 1. And so all the scanner had to do is sequentially increase the number by 1, so go 2, 3, 4, and it would end up in things that it should have been authenticated in order to view. So over here, if you change it to 2, you enter Bob's account, right? If you change it to 3, you enter Mary's account, or so on. And that's something that you don't need to be very smart to kind of like figure out and test for, right? But what the scanners did when we looked at the behavior of the request that it was sending is that they were sending random data to those parameter values. So they would send like a huge string of values, and that was just not valid, right? Because the logic of the application is that it increases sequentially, right? And so all of them except for Arachne weren't able to enter an authenticated page, but Arachne did enter an authenticated page, but it had no idea that it did exploit a vulnerability. It had no idea that it actually entered a page that requires authentication, and so it never reported it, right? So forceful browsing, similar to parameter manipulation, you had a high quality version of a picture that you were only supposed to view as an authenticated user who bought that picture, who bought that high quality link. And so the application didn't have the proper access control rules that said, Rana bought this high quality version of the picture, so only Rana can see it in authenticated mode. And so you could just enumerate it by brute forcing the PC ID. And again, none of the scanners were able to do that, and none of them found that vulnerability. And these are pretty high vulnerabilities. Like if I was on a vulnerability assessment, I would categorize these vulnerabilities as high. And then logic flaw, this one's pretty obvious. The scanner has no way of understanding the business logic of the application. So in this case, the coupon management system, you enter a coupon, the developer assumed that you will only enter it once, whereas you could enter it multiple times until you get your entire purchase for free, right? So it doesn't count the number of times that you've used it or if you've used it before. And so none of the applications were able to do that, which is, again, none of the scanners were able to do that, which is, again, scary because most of the vulnerabilities that we find in our vulnerability assessments are logic flaws. Okay, so before I get to the next slide, there were also other vulnerabilities that were not detected by the scanners, things like vulnerabilities that required complex vulnerabilities. So vulnerabilities that required a human being actually sending characters to the web application, seeing how it responds, and then building your query based on the responses. So it usually takes several iterations before you get the exploit right. So vulnerabilities like that, so stored XSS, blind SQL injection, blind SQL injection, and so on. Vulnerabilities like that, the scanner was not able to find. So the question is, can scanners catch everything? They try, and they catch some stuff. But yeah, like they're actually trying, and I'm not sure if they actually caught anything at the end, but anyways. So this slide is stolen from my coworker's talk at AppSec USA. It was done in 2017. The talk was pretty good. It's called a hybrid approach to web application penetration testing, and he has a whole ideology, I would say, of not using tools at all when he does his tests, which is quite interesting. I don't agree with that. I use some tools, but anyways, you should watch the talk. Okay, so we found that on average, scanners only find close to 40% of the vulnerabilities. And in my opinion, that number could be even lower depending on the data set that you have and the type of vulnerabilities that the scanners, that the applications have. We tried to have a level data set with over 1,000 vulnerabilities on many applications. And we found that on average, they find less than 40% of the vulnerabilities. And they're usually the low-hanging vulnerabilities. Okay, so we discussed the vulnerabilities that the scanners can't find. So if a scanner has a bad attacker and analysis module, then the chances of it finding a vulnerability is low, but it can still find it, right? But if a scanner has a bad crawler module, the chances of it finding a vulnerability is close to zero because it needs to crawl the application, find the page, and then look for vulnerabilities in that page. If it never got to that page in the first place, it's not going to detect the vulnerability. And we'll see examples of that in a bit. So things like uploading a file, which is very common in web applications today. The scanners weren't able to upload a file, so any page that existed behind that upload functionality, the scanners weren't able to get to it. So if that page was vulnerable, the scanners wouldn't report that vulnerability, not because they can't detect that vulnerability, but because they never got to that page that had that vulnerability in it. And so when we actually held the hand of the scanner and said, this is exactly how you upload a file, in train mode, Burp and Zap were able to do it. Authentication. Most scanners were able to create accounts, as you can see in the table over here, except for Wapiti. It wasn't able to create an account. But when we checked the behavior of the scanners, we realized that although they're creating so many accounts, what they were doing is throwing random input values at the input parameters in that creative user page. And so they weren't aware that they were creating an account. It was a byproduct of them throwing values at that form. And the reason behind that is, and the reason we concluded that is because none of the scanners actually used so for example, the 200 accounts in order to re-authenticate to visit authenticated pages. So they created accounts and they had no idea that they actually created those accounts. And so they never used them in the next steps that they conducted. Okay, multi-step processes, again, very common with web technologies today. So in this case, in order to add a comment, you had to preview it first and then create it. So it's a two-step process. Most scanners in point and shoot mode would get to the preview page, click on the link, and then that was it. They weren't able to follow that flow of tasks in order to complete it and get to that comments page. And the comments page was vulnerable to XSS, which all the scanners detected in train mode after we actually showed them exactly how to do the multi-step process. However, in point and shoot mode, they didn't detect the XSS vulnerability because they never got to the page in the first place. And that this goes to show that the crawler component is actually very important when it comes to a web application vulnerability scanner. Okay, infinite websites. Thankfully, on a lighter note, all the scanners except for Arachne were able to detect that there's an infinite loop on the calendar page. Arachne ran, I think I let it run for like a good 8 hours before I decided to terminate it. But so in cases like this, it shows that you need to actually play around with the application manually, understand how it works, what points might break a scanner, and then configure your scanner so that it doesn't hit obstacles like this one. And in the case of Arachne, you could either say, avoid this page completely or visit this page only 3 times. After the 3rd time, then stop visiting this page. And this way you would avoid the infinite loop. Okay, state awareness. Again, very important is that scanners are not very state aware. They're not state aware at all, actually. And so the idea is that if you give it login credentials, then it has a valid session ID. So it'll enumerate all the different links within the authenticated state, right? And so if it accidentally hits a logout button or does something that invalidates your session because the application is seeing you as an attacker, or the controls that the application employs is seeing you as an attacker, and it invalidates your session, any requests that happen after that are in unauthenticated mode. So you could be trying to access, a change password page, but in reality, the application would respond that you don't have a valid session, and so you can't test this page. And if you don't actually monitor and review all the requests that the scanner is making, you might think that the scanner is actually testing your entire site, as opposed to erroring out on everything because it accidentally unauthenticated itself. And I'll stress on that a little bit more later, because a lot of people don't do that, because by default, Burp doesn't show you the request that the scanner is making. So you have to install a plugin. There's one called Flow that you actually see it. And I have an example, like a real life example where that actually happened. And we weren't sure why all of a sudden the scanner is erroring out and everything. And then we figured it out after looking at the requests. And the scanner doesn't tell you that it errored out or whatever. It just says, okay, no vulnerabilities in the access denied page, no vulnerabilities in the access defined page. And so you would have no idea. Client-side code. So this is the last one. So the Whippet application, that's the application that measures the crawling coverage of a scanner. So it contained things like standard anchor links, which all scanners were able to crawl. Links that were created dynamically using JavaScript. That was a little bit more difficult for scanners. Multi-page forms, very difficult if you don't show the scanner how to do it. Links and comments, again, developers leave a lot of important information in comments. That's how you enumerate your targets. And so if it's able to recognize that it is a link using regex in the comment, and it actually goes and visits it, links embedded in Flash objects, and most of the scanners weren't able to detect that, but that's fine because that's getting phased out. And then links within AJAX requests. So Arachne, surprisingly, had a really high crawling coverage. It was able to crawl through about 94% of the technologies, and ZAP came in second with 78%. But with ZAP, you had to enable the AJAX crawler, and you had to actually configure it from the inside, going like, visit this element, and this element, and this element, in order for it to achieve the 78. Before that, I think it was close to 50, which is similar to the other ones. Okay. So now that we saw all the results, so what now? Should Johnny even bother using an automated scanner? And the answer is, does anyone want to guess? Yeah. Yes. Okay, good. Yes, Johnny definitely should use an automated scanner. It's just that he should be aware that scanners do not replace a skilled pen tester, but they can aid a pen tester or a security assessment analyst. And something that he really needs to be aware of, because he thought he was a genius, he figured out the whole security thing on his own by using a tool, is that a vulnerability scan is not equivalent to a vulnerability assessment, and it's sure not equivalent to a pen test, right? And I say this, and it seems a little bit obvious, but in the corporate environment, not everyone is aware of that. Because I have like project managers tell me, so did you run a scan? I'm like, no, I manually tested it, which is by far one, accurate, less noisy, and so on. So many advantages. And then they go like, well, I don't feel comfortable until you run a scan, just to make sure you've covered all your bases. So, yeah. So even when you do use these tools, it requires a lot of skills. I saw this in a previous presentation. I'm like, I'm definitely going to use it in mine. So a fool with a tool is still a fool. Yeah. Yeah, it requires a lot of skill to configure these scanners. In certain situations, it might take you hours to understand how the application is mapped, and then to configure your scanner in such a way to make sure that the scanner covers all bases in your application. And that involves a lot of things. So you never run it in point and shoot mode like Johnny did, and like so many people actually do because it's advertised that way. You really can't blame people for doing it because that's how the scanners are advertised. So you have to first specify the target. You don't want to click on links that you're not allowed to test. Most scanners are smart enough to know that if you specify this URL, then it won't visit anything outside of that domain. You have to set login and logout conditions. Again, like I said, you have to hold the hand of the scanner and go like, this is exactly how you log in. And it might get more difficult if you've got two-factor authentication based on the second factor. You might be able to do it with a scanner. On other cases, not so much. And then you have to specify the logout conditions so that it doesn't end up hitting the logout button and then running all the other requests in unauthenticated mode, right? You have to set the scanner in proxy mode and visit every page of the application. That's to ensure that the entire application, that the scanner is aware of all the links that are available in the application, just in case it can't crawl them, which we saw is difficult for some of the scanners. And then you have to configure scenarios, business flows, and clean up between scenarios. So the example that I mentioned earlier is with CSRF tokens. I was working on a vulnerability assessment where we did the vulnerability assessments, and then they took our recommendations and they fixed the code. And then we're doing another vulnerability assessment. So we ran the same scan on the next time around. And so all of a sudden, when we look at the requests of the scan, they were all erroring out. And so when you actually looked at the different requests, it turns out that the developers had added a CSRF token, so a cross-site request forgery token that refreshes with every page. And so the first request passed, but every other request didn't pass because the scanner had no idea that it had to take the CSRF token of the previous page and then insert it in the next request, which is common for web applications, right? And so we had to actually use a plugin to configure the scanner to take the CSRF token from the previous page and use it in the request. And that's something that gets done automatically right now with the scan. So things like that, we would, if you weren't monitoring and reviewing the requests of your scan, you would have no idea that the scanner is not actually testing your application. It would just appear that the scanner tested the application and didn't find any vulnerabilities when in reality, it wasn't doing that. And then after all that work, you're actually only protected against script kiddies because scanners can only find the low-hanging vulnerabilities and the not so complex vulnerabilities, so the simple vulnerabilities. And so, yeah, even after all this work and knowing how to configure the scanners and how to run them right now, that's why Johnny still can't pen test. And he's a bit of a drama queen, which is why you'll see the reaction. So you'll see right now. That's okay. He got over it at the end, and now he's learning how to pen test. Yeah, it escalates. I'm not sure we're gonna let it escalate to the last one, but here you go. That's enough. Anyways, yeah, he gets a gun at the end, but this is this is how you get in touch with me. I'm most active on Twitter, so if you need anything, Twitter would be the place to go. The last one is my research that I conducted at university. So if you want to read 106 pages of the work that I presented today, you could get it there. It's not as fun and hopefully as exciting as this presentation was, because it doesn't have a storyline, but it does have all the details of the pen test and the vulnerabilities that each scanner was able to detect the vulnerability categories and in which mode they were able to detect them. And that's it for my presentation. Thank you.